Hi, Algebra 1. In the beginning of Unit 4 here, we're going to be looking at function notation, which is just a short way to write about functions. Here we go. First, we're back to the problem with the dog on his leash, which is attached to the post. We have three graphs of day 1, day 2, and day 3. And this is just a reminder of how we write about functions. You're going to have to write this down. It is not in your book. But in this case, we're going to be seeing that the distance from the post is a function of the time in seconds. We can see that on each graph for each day, 60 seconds after the owner left, the dog was 4 feet away from the post. Next question, how far away was the dog from the post when the owner left? On day 1, we can see that when the owner left, the dog was going to be 1.5 feet away from the post. And we can see that that was true for the other 2 days as well. The owner returned 160 seconds after he left. How far away was the dog from the post at that time? So here's 160 seconds. Right here is going to be how far the dog was away. This looks like it's going to be about 3.8 feet. On day 2, after 160 seconds, the dog was 4 feet away. And on day 3, the dog was about half a foot away after 160 seconds. D, how many seconds passed before the dog reached the farthest point it could reach from the post? So we have to look at where the farthest point is away from the post. And here it looks like it was at about 50 seconds. On day 2, it looks like it was farthest away at about 35-ish seconds, somewhere in there. And on day 3, it was right away. I put 2 seconds. You could say 1 second, 3 seconds, something like that. Number 2 says, consider the statement, the dog was 2 feet away from the post after 80 seconds. Do you agree with that statement? Well, here at 80 seconds, the dog was about 2.5 feet away. Here at 80 seconds, it was 4 feet. Here at 80 seconds, it was 2 feet. So that statement, I would agree only on day 3. It depends what day you're asking, specifically whether you would agree or disagree. Number 3, what was the distance of the dog from the post 100 seconds after the owner left? Here too, it's going to depend on the day. So there's more than one answer you could give depending on which day we're talking about. So since we don't know what day we're talking about all the time, it's going to be helpful to name these functions. And this is where we are getting into function notation. We are going to name these functions function f, function g, and function h for day 1, day 2, and day 3. And we're going to use that function notation to complete the table. When I say function notation, what I mean is just how to write the names of these functions when we are using them in math. So looking at this table, we're first looking at the distance from the post 60 seconds after the owner left, and we want to know this for day 1. Day 1 is named function f, so in function notation, I would say this is f of 60, meaning function f, day 1, 60 seconds into our time. For day 2, we would call this g of 60, meaning function g, day 2, 60 seconds into our time. And for day 3, I would call this h of 60, meaning function h, day 3, 60 seconds into our time. B, the distance from the post when the owner left. That's going to be at 0 seconds right away into our time here. So for day 1, I would call this f of 0. F meaning day 1, function f, 0 meaning right away at 0 seconds. Similarly for day 2, I would say g of 0, and day 3, I would say h of 0. And for the last part, the distance from the post 150 seconds after the owner left, I would say f of 150, meaning day 1, function f, 150 seconds after. G of 150 would be day 2, and h of 150 would be day 3. So now they're going to give us function notation. We're going to interpret what it represents. So A is saying f of 15. So this means function f. So day 1, 15 means 15 seconds in. So this little tiny bit of writing, f of 15, means the distance from the post 15 seconds after the owner left on day 1. So you can see why function notation is a lot easier to write. It's much shorter. B says g of 48. So that's talking about function g. So we'd say on day 2, this time we're putting the day first, the distance from the post 48 seconds after the owner left. And C says h of t. So h is referring to function h, day 3, and t is just saying t seconds, so any number of seconds. So in words, it would be on day 3, the distance from the post t seconds after the owner left. In number 3, they give us an example and they say the equation g of 120 equals 4 can be interpreted to mean that on day 2, that's function g, 120 seconds after the dog owner left, the dog was 4 feet from the post. So all of that is given in just this function notation. So in A, we have h of 40 equals 4.6. So this h means function h. So on day 3, 40 seconds after the owner left, the dog was 4.6 seconds away, or 4.6 feet away from the post. And we can see that as this point right here on the graph. B says f of t equals 5. So this is saying that on day 1, function f, after t seconds, the dog was 5 feet away from the post. Now we could look at the graph and figure out when the dog was 5 feet away from the post, but right now we're just interpreting what this function notation means. And C is now in all variables, but we can still figure out what's going on. Function g, that's right here, so g of t, so that means in function g, day 2, after t seconds, the dog was d feet away from the post. Okay, so to wrap up our function notation, there's a few things that are being shown here. First, the name of the function is the letter that comes first. So we had named our functions f, g, and h for day 1, day 2, and day 3. The input of the function is here in parentheses. In this case, it was time with our dog. And then the output of the function is what it equals. In this case, it was d for distance. We can use any letters we want here as variables. The way that this would be read, we would say out loud, f of t equals d.